tour of us. Before an apple ever reaches a factory, its journey begins here. In carefully engineered orchards.
Every leaf is a solar panel. It converts sunlight into energy through photosynthesis by feeding.
Water is delivered through precision drip irrigation systems. Instead of flooding fields, tiny droplets feed the roots directly.
Even pest control is smart. Instead of heavy chemicals, many orchards use pheromone traps, harmless scent markers.
These crates are specially engineered. Rounded corners prevent bruising. Perforated walls allow cool air to circulate.
Before they hit the road, the apples are pre-cooled to just above freezing, usually between 0 and 2 degrees Celsius.
Refrigerated trailers, known as reefers, act like mobile cold rooms. Insulated walls and sealed doors maintain temperature. Cold air circulates gently from ceiling vents. Sensors inside the trailer constantly monitor temperature and humidity.
Even vibrations matter. Special dampening pads under the crates reduce shaking from the road. Without them,
each crate carries an RFID tag, a digital identity. This allows the factory to trace every apple back.
when the trucks finally arrive, the cold chain has never been broken. From orchard to factory, the apple...
The sorting accuracy on line 3 has improved by 2% this quarter.
Yes, the new calibration seems to be working perfectly.
To avoid bruising, apples are transported using a water flume. Buoyancy supports their weight, while a slow current guides them along. From the water flume, the apples transfer onto food-grade conveyors. Brushes remove excess moisture, aligning each fruit into a single lane.
Here, the real intelligence begins. Arrays of high-speed cameras capture every apple from multiple angles.
Hidden beneath the belt are microscales that weigh each fruit. Weight reveals density, and density affects texture.
The AI compares every surf pixel to millions of reference images. If it detects a bruise,
The first stage is a rotating drum washer. The drum slowly turns while filtered water sprays across the apples. To ensure food safety, the water is treated with food-grade sanitizers, such as chlorine dioxide or ozone.
Next, rotating nylon brushes polish the skin. This removes the last traces of dust while smoothing the surface.
High-velocity air knives remove moisture without heat. Dry fruit prevents microbial growth, and
apples naturally produce wax to lock in moisture. After washing, some of that wax is removed.
Inspection systems ensure every piece of fruit meets strict hygiene standards. Bright inspection lighting sometimes is behind the scenes. Advanced filtration systems recycle wash water, removing particles and sand.
Once cleaned and polished, only the finest apples move into the precision cutting line, where engineering and food science work.
Before slicing, the apples must be perfectly oriented. Rotating rollers align each fruit so the stem faces up.
The blades are made from surgical-grade stainless steel. This material resists corrosion, stays razor-sharp, and ensures evens.
High-speed slicers divide each apple into uniform wedges within a fraction of a second. The cleaner the cut, the fewer... Coring punches remove the seed structure in one smooth motion. Transparent safety shields protect workers. When apples are cut, oxygen reacts with enzymes in the flesh, causing browning. To prevent this, the slices are briefly...
Time and temperature are controlled to the second. Too long and flavor changes. Too short and oxidation begins.
From here, the slices continue their journey. destined for desserts, ready-to-eat packs, or bakery fillings. Only the highest grade apples move forward to become desserts. Here, food science meets artistry, transforming
These giant kettles are steam jacketed, meaning hot steam flows through a sealed layer around the kettle walls.
As the temperature rises, natural sugars begin to caramelize, deepening color and sweetness.
For apple sauces and purees, vacuum concentrators remove excess water at lower temperatures. Lower pressure means
The weight on these looks consistent. Yes, the apple mixture is holding up well.
Industrial ovens circulate heated air evenly across every tray. Moisture vents control humidity, keeping crusts crisp. Microbial tests check for unwanted bacteria and yeast. Growth plates are incubated under controlled conditions, Sweetness is measured scientifically using a refractometer. This device calculates Brix. Texture matters just as much as taste. Mechanical analyzers measure firmness and bite resistance, the science behind that satisfying apple crunch. Every sealed product passes through X-ray or metal detection systems. These scanners identify even tiny foreign parts.
Special environmental chambers simulate real-world storage and transport conditions. By accelerating time, scientists predict
only when every test is passed, safety, sweetness, texture, and purity is the batch released for packaging.
Once every test is passed, the apples and desserts enter the packaging hall, where freshness is protected by engineering.
Robotic handling systems portion each serving with amazing precision. Vacuum grippers are designed to be soft and flexible.
Heat sealing units bond the protective film to the tray edges. Optical sensors and pressure tests confirm that every seal is...
Labels do more than show a name. Barcodes and QR codes store the product's entire history. Orchard, harvest time,
Robotic case packers group trays into shipping cartons. Palletizing robots then stack each box with perfect...
Finished products enter climate-controlled storage.
We need to prioritize the seafood pallets for Truck 4.
Copy that. Moving them now. The temperature needs to hold at 35.
Once production is complete, a sophisticated network takes over. Distribution logistics.
Products are loaded directly into refrigerated trailers. Temperature-sealed docks prevent warm outside air from entering.
Each shipment carries sensors that track temperature, humidity, and travel time. If conditions drift outside the safe range, alerts trigger.
As trailers travel regional highways, refrigeration units continuously circulate chilled air. Even long distance. At major distribution hubs, pallets rarely stop moving. Cross-docking systems scan, sort, and
intervals. Even in stores, engineering continues to protect quality. Chilled displays, humidity misting, and cushion-back trays
packaged desserts stay sealed in controlled atmospheres, locking in color, texture, and aroma until the moment the customer opens them.
And finally, the journey ends where it truly begins, at the table.
Apples contain over 300 natural aroma compounds, tiny molecules that give each variety its signature character.
Great apple flavor lives in balance between natural sugars and gentle acidity. Technicians measure Brix and
Beyond taste, apples provide soluble fiber including pectin, bitsurisu, which supports digestion.
Even labels are engineered carefully. Serving size, energy content, and allergen information are calculated to international standards, giving consumers clear, honest guidance.
Modern apple production helps reduce waste and stabilize supply. Advanced grading and preservation.
And in the end, all the science, engineering, precision, and care come together in a simple, shared moment.